Hello guys, I'm Sandip from askIITians and let's learn some physics today. Okay, so today we are going to start a new chapter which is called as force. Very interesting chapter, right? Why I'm saying interesting? Because we are going to use this chapter, this forces concept in our everyday life. Okay, so now what you can see on the screen, one person is there. Obviously, everybody knows the name of this person. Who is this? That's right. That is Isaac Newton. We know the very famous story that the apple falls on his head and then rest is history, obviously. Right. But is that the gravity, that apple thing, is the only thing he invented or studied? No. I have put one image here where you can see a lot of things there. He's holding some prism and there is a diffraction, dispersion of light into different colors, right? Also, I can see sun and the planets are revolving around the sun there. Moon, oceanic waves, something there, then our telescope thingy there, right? So Newton not only studied gravity, but have studied a lot of things, right? So remember, at least until 12th, Newton is our most famous and scientist we are going to study, right? And a lot of theories, a lot of derivations are put there by the Newton. Okay, so as I said, today's chapter, that is force, is going to be very interesting. Now let's talk first, what is force, right? So consider one very simple situation. Consider your family goes on vacations, right? That's good. Now your whole family is going on vacations, your mother, your father, your brother, and you, right? Let's say you are going on a vacation and at some particular point, at some point, your cars break down. What will happen? Your father asks you and your brother to go and push that car, right? Obviously, you cannot go because someone needs to be on steering, right? We know this thing, simple. So consider your brother goes out and start pushing like this, okay? And also you went down and now consider you also start pushing this car, but from the front. So you apply the force on the car on the front. What will happen? One thing I'm very sure of, that your father will be very angry. Why? Because this is not the way you push the car. Simple. What do you have to do? You have to go back with your brother and then start the pushing car from this side. Very simple thing, right? So what I'm saying, one word is very important: pushing the car, right? So you are applying the force, means pushing the car, right? So can I say, tell me one thing, can I say pushing is some kind of force? Is it? Maybe. Now let's take consider another situation. Now, even though you're pushing that car, but this car, obviously we know it is very heavy, so it is very difficult to push that car. So you're not able to push that car, right? What you guys will do? Obviously, now you're going to call tow truck. So tow truck, just let me draw it bigger, obviously. Okay, so I can say this is the tow truck. Let's call this as tow truck. What is the purpose of this tow truck? It is going to attach one cable to your car like this, and now this tow truck is going to pull that car, take that car up to garage, right? So again, I will repeat, that tow truck is going to pull that car, your car, up to garage, right? So is it applying the force? Yes. But you applying the force? Yes, right? You are pushing, tow truck is pulling. Both objects are doing the same thing. Obviously, the force applied by you on the car will be small, but the tow truck can apply a lot of force and obviously can take that car to the garage, right? So this pushing and pulling, or push and pull, are called as simply force, right? Simple. So what I can say, force is the push and pull, right? Okay. Now, initially I told you that if you went on the front side of the car and start pushing that in the opposite direction, it is not going to work. Why it is not going to work? Obviously, your brother is pushing from behind, you are pushing from the in front of the car. What will happen? Force of your brother, force because of you will get nullified, we can say, and there will be no effect. Car will not be pushed, right? Therefore, remember, force also need magnitude. Magnitude means how much force you are applying. It also needs direction. So direction is also very important. In which direction you are applying the force. Okay. Now let's watch this very small video for push and pull. So it will get our understanding very clear about the push and pull.
Video, we are going to learn about how people can make things move, like how this boy is moving these magnets. Cool, huh? We are going to be talking about two forces that move objects. These forces are called push and pull. You use these two forces every single day. That's right. We want to help you know the difference between a push and a pull and how to identify them so you know exactly how you are moving the objects around you. First, a rope. Yeah, not very exciting, not super exciting. It's just a rope sitting there. But have you ever played this game before? Now, all of a sudden, we're having lots of fun, aren't we? What is this game called? Yes, Tug of War. Yeah. Tug of War is a game that is played all over the world and was even played in ancient Egypt and ancient China. In Tug of War, you want to move the rope toward you until you've won. It's all about moving the rope. Applying force on an object toward you is a pull. Pulls bring objects toward you. That's what a pull is. Here, the children are pulling on the rope. They are moving the object toward them. They're moving the rope toward them, aren't they? So, what are pushes? Well, a push is the opposite. Pushes move objects away from you. Can you say that with us? Pushes move objects away from you. Fantastic. Wow, do you know what this girl is doing? Uh-huh, she is building a snowman. But she is just getting started. Whoa, look how big this snowball has gotten. She is using force to move the ball away from her. These are called pushes. She is pushing the snow along. Here's another push. This boy is pushing this girl in a car. Whew. Pushing can be hard work. The difference between a push and a pull is in the direction it is going. A push moves an object away from you. A pull moves an object toward you. You try now. Is this a push or a pull? Yes, a pull, because they applied force to move the rack toward them. This is a pull. Okay, so we're just gonna watch them load up dishes, huh?
Okay. So here we understood what is the push and pull. We also saw that push means object is going away from us. Pull means object is coming towards the object which is applying the force, we can say, right? So this push and pull is called as force. Simple definition we can make of the force. Okay. Now let's see what topics we are going to cover in this case. Force, we already know now definition of force. You can see it is the push and pull. Then what are the balanced and unbalanced forces? Now you can consider the words, right? Balanced. Balance means everything should be in proper order, right? Unbalanced means what? Right? In detail, we are going to study those. State of motion. What you can say about the state of motion? State of motion means how much velocity you have. Also, what is the rate of change of velocity? Do anybody know what is the rate of change of velocity? That's good. That is acceleration, right? So you know the velocity. Then, so state of motion is what? Whether it is at rest, velocity is zero, what is the velocity, or velocity is increasing, acceleration is there or not. We are going to study all those things, right? Then contact and non-contact force, as the name suggests, it is very easy to understand. Contact means there should be contact between two forces, right? Two objects we can say. And non-contact means there will be no contact in between two objects we can say. Simple. Equilibrium. Equilibrium means what? Again we can say everything is in balanced condition, which we can call it as equilibrium, right? So even I can I say that balanced and equilibrium will have some relation in between them. That's right. Okay, so let's see what are all these topics, right? Now, definition of force, as we already know, that the push or pull which can change the state and the shape of the body. State means what? Whether it is at rest, whether it is moving, that will change this thing. Then it can also change the shape of the body also, right? So this is a simple definition we can say. Okay, you already seen this. Here you can also see some examples there. Horse is running. Obviously, he needs to push the ground here, right? So he is pushing this ground here. Obviously ground is not going to move, but what we can say, if horse is pushing the ground will also push him, right? You must have heard Newton's third law of motion. Every action has, that's right, every action has equal and opposite reaction. That's good. So if horse is pushing the ground will also push the horse. That's why he's able to run, we can say. Then here you can see this person, this boy is pushing that object, right? Here he's trying to pull that small object above his head, we can say. Then this person wants to keep that object onto the chair, right? So all these things are nothing but the examples of push and pull, or simply we can say force. Okay, now tell me one more thing. We must have heard something called as SI unit. Every quantity has some SI unit. What is the SI unit? Or let's say any unit, right? So consider you went to the shop and let's say to buy some sugar, right? How much sugar you normally buy? Consider to shopkeeper, you will say, give me 1 kg of sugar. 1 kg of sugar means he will give you, I will weigh that sugar on his balance. There must be some balance, right? Nowadays there is electronic balance, obviously, right? So he'll measure that 1 kg sugar and give it to you, right? So this is the unit. So similarly, every quantity will have some unit, right? Like this is the mass quantity, we can say, right? Then you also measure time. Time is also quantity. What is the unit of time? Normally we say 1 hour. Consider there is a 1 hour lecture, right? Or 2 hours lecture, right? But SI unit means the standard unit, we can say it is 1 second. So we are going to measure time in second. Similarly, this force I want to measure, the unit for this force is going to be 1 Newton, right? Why Newton? Obviously we know Newton is our favorite scientist now, up to the 12th now, right? Okay, so 1 Newton is the unit for force, we can say. Okay, now tell me, there is one more thing we can consider. How many forces do you know? You know any forces, types of forces, I can say, right? Oh, let's say gravitation force, right? Simple. That's good. Gravitation force we have. Then we also have tension, friction. Good. What else? What are the different types of forces? Anybody knows? Yes, gravitation there, tension there, friction there. Then there are air resistances there, buoyant forces there, drag forces there. So there are many types of forces, right? But in nature, remember, there are four fundamental forces. Four fundamental forces, right? First one is called as gravitation. Now we all know that important force, gravitational force, that this is the force between any two objects. I'm saying it is the force between any two objects we can consider, right? So even consider your laptop or mobile is here, and let's say your notebook is kept here, right? So even these two objects also have gravitational force between them. And always remember, this gravitational force is an attractive force. This is attractive force, means as I'm saying, these two objects should attract each other. They should come closer, right? But is it happening? No. Why is it not happening? Why these two objects are not coming each other towards each other? Right? There's an attractive force. There's a gravitational force between these two objects. Still, they are not coming towards each other. Why? Reason is very simple. This gravitational force, the formula for this is given by G m upon r square, where I can say m1, let's say call this as m1 and m2. M1 and m2 are the masses of laptop and let's say your notebook. R is the distance between them. And this G is a constant. It has a constant value. The value of this G is very, very small. This is 6.67 into 10 raised to minus 11. So if you talk it about the in point system, it will be 0.00000 up to 11 zeros, then you will have 667, right? So this quantity is very, very small. So we can see, even though there is a force between these two objects, it is very small, right? So as it is very small, we can say that these two objects will not attract each other, right? So one more thing in gravitational force, you should remember, it is the weakest force in nature. Weakest force found in nature, right? So this is our two things you should remember about the gravitational. Then let's talk about the second type of fundamental force. Second fundamental force is called as, let me write it here. Yes. So second force is electromagnetic force. Electromagnetic force. Obviously, as the name suggests, we can say it is the force between, let's say, electric charges, right? We must know that this is the, let's say, plus charge. We know the proton and electrons, right? Protons are positively charged. So we can say force between two protons is also electrostatic force, right? Magnetic force means bar magnet. We already know magnetic force. It attracts the ion, etc. Right? So, right now, if these are the two protons, let's say positive protons, right? Positive repels each other, right? So this force could be repulsive, or I can say positive negative attracts each other. So it could also be attractive force. Right? So electromagnetic force could be repulsive and attractive. Obviously, it is stronger force than the our gravitational force. Then third type of force is a strong nuclear force. Strong nuclear force. So what is strong nuclear force again? Right? Now we already know in proton there's an electrostatic force. Right? But in proton there is another force which is called as nuclear force, right? Strong nuclear, as the name suggests, we can say this is the strongest force. This is the strongest force found in nature, right? Also, one more thing we should remember about this force is it has a very short range. Short range means nuclear, as the name suggests, it must be inside the nucleus, right? In nucleus of the atom. What are the particles in the atom, right? This is the electron revolving around the nucleus. Protons are there, neutrons are there. So only in protons or neutrons we can say there will be strong nuclear force, right? So range is very, very small. We already know we cannot even see the atom. So nucleus is not possible, right? Obviously. So this force acts at a very small range, we can say, right? Then next force we have, it's a weak nuclear force. So similar to strong nuclear force, this is the weak nuclear force. Though remember, though the name suggests weak nuclear force, it is not the weakest force. Weakest force, I already told you, the weakest force is the gravitational force, right? Okay. So even remember this part when you are going to go into the 11th and 12th, going to prepare for your exam for JEE as well as NEET, then this concept is very important. The theory part I'm talking about, right? The gravitational force is the weakest force. So they are going to ask you one question. Let me write the question. Which of the following Question will be something like this. Which of the following is the weakest force? Right? They will also provide options to you. First option, let's say weak nuclear force. Weak nuclear force. Tell me the other forces we have already seen. Strong nuclear force, that's right. Strong nuclear force. Which one is the third one? Third one is electromagnetic force. I have replaced the orders, right? It is not in the correct order, which I have written earlier. Electromagnetic force. And another one is gravitation force, right? What is the question? Which of the following is the weakest force, and what should be the answer? I told you the gravitation force is the weakest force found in the nature. Okay, so these are the different four types of the forces we can say. Now let's come back to our PPT and let's see. Next point is balanced and unbalanced force. Now we want to talk something about the balanced and unbalanced force. As I already told you that the balance, what is the balanced force? Balance means everything should be in order, right? So here you can also see there is something like seesaw, right? I know that everybody played seesaw in their childhood, right? So what happens on seesaw? One person sits on this part, and the other person sits on this side. What happens, that seesaw is going to rotate like this, not rotate we can say, but we can say it is oscillating like this, right? Why it is oscillating? If this person applies the more weight, it is going to go down. Or we can say if this person has a lot of mass, or we can say maximum mass or greater mass than the another person, obviously this side of the seesaw is going down, right? So when that seesaw is going to be in stable condition, when both the childs will have the same weight, we can say same mass, then it will be in the balanced position, right? That's what we are going to call this as balanced position. Okay, shallow. So also you can see this the diagram. There are two forces kept here, two blocks are kept here, right? Both have the mass, or let's say weight 500 500, right? Unit we can say unit is, let's say, Newton. We know the unit of force is Newton, right? So let's say weight also has the unit of Newton, right? Remember, mass and the weight, these are the two different things, mass and weight. Normally what we say, if somebody asks you what is your weight, normally we say that, let's say our weight is 40 kg. But remember, 40 kg is not our weight. 40 kg is actually our mass. So what is weight then? Remember, weight is, formula is m into g. M is your mass, that is 40. G means, anybody know what is G? G is acceleration due to gravity. What is the value of G? That is 9.8. Let me substitute here 9.8. Right? So if I solve this one, how much should I get? 392, right? So 392 Newton. Weight has the unit Newton, that is same as that of force, and mass is just kg. So when we say our weight is 40 kg, it is not a weight, it is actually the mass. Weight is actually 392 Newton, we can say. Okay, now let's come back to our question here. What is balance and what is unbalanced force? As we know that this seesaw is going to remain stable. Stable means what? The forces should be same. Forces on where? On the both the branches, we can say, both the sides, we can say. So now here the forces are going to be same. So here we can see 500 Newton, 500 Newton. So we can say this is the balanced force. Okay. When you say it will be unbalanced, obviously this block should have some different masses, or we can see the child so who have different weight, right? Obviously that seesaw will oscillate like this. Okay, so that we can call this as unbalanced force. And this one is where the masses or weights of the blocks or the childs on the seesaw are same, then it is going to be balanced force, right? Not only this, I told you the first at the start of the lecture, I told you one example, right? If Your brother is pushing the car from behind, you are pushing it from the front, right? Now instead of car, let me consider any object or consider a door. Now you are in your room, your door is locked. Now consider if you want to open the door. Your friend came and you want to open the door, right? Now consider if you are pulling this door. We know the pulling and pushing are what? Forces, right? If you are pulling the door, and now consider your friend from other side pushing this door. Sorry, pulling on the other side. You are pulling on this side. What will happen? Will door open? Obviously not, right? Why? Because you're applying the two forces there. And if the magnitude of two forces, assume 10 Newton, 10 Newton forces, you both are applying, this door is not going to move, right? Or open, right? And I can say this condition is a balanced condition. Even though there are forces in the system, forces on the door, still it is called as a balanced system, right? Or balanced force. Okay. Now, what we should remember about the balanced force? Two things are very important. Remember, balanced force. First thing, balanced force cannot change velocity of object, obviously, right? Now, instead of door, consider one block is placed here, big block, right? Or car you can consider, right? If you apply the force from the both the sides, what will happen? We know that it cannot change the velocity, so block is going to be stable at the rest, right? But if you increase your force, right, what could happen in this case? That shape, this shape will change, something like this, right? It may become something like this if the force is very, very high, right? Maybe you are using some machine or something there, right? If the force is very high, right? What I can see here, that shape, before it was very square type, or in 3D I can say this is the cube type, right? In 2D we can only see the square from the front view, cube in the 3D we can say, right? So it will become something like this, right? So again, if I draw this part in 3D, it will look something like this, right? So what have happened here? The shape is changed. So what I can say, second point, which is very important for the balanced force, we cannot change the velocity, but the second point says balanced force can change the shape. Simple. Okay. Now this is about the balanced force. Now, next we know that there is a balanced force, and another point is unbalanced force. Now let's talk something about unbalanced force. Okay. Now what is unbalanced force? So again we can consider this door, right? Same door. Now you want to open. You both were actually pulling the door. Now you told your friend that don't pull the door, I will open it, right? So what will happen? You are going to pull this door on your side. Now you will tell your friend, push the door. Instead of pulling the door, push this door, right? So he will also apply the force in the opposite direction. Let's say 10 Newton, 10 Newton. This is the force. What will happen in this case now? Obviously. Now, in the previous case, in balanced case, what we have said, 10 Newton are in opposite direction. He is also pulling in his direction. You are pulling in your direction. So here also you can see by the notation or the diagram that two forces have the different directions, right? But in this case, what is happening? Both the forces are in the same direction. Now, what will happen? Obviously, door is going to open, right? Simple. If I keep the block here, if I apply two forces like this, what will happen? This block will start moving, right? So it will go at different point, right? Because of this force, I can say. Simple. So in unbalanced force, what we can say, object will not stay in the rest, right? So simple, what you are supposed to remember about this unbalanced force. First thing, it can move stationary object. This is the first point, right? Remember, it can move stationary object. Then second thing you should remember about this, it can also stop moving object. It can stop moving object, right? Right, you must have seen in the movies or something, right? If the train is moving very high, I think in Spider-Man, you must have seen in Spider-Man, train is out of control, it does not have any brake, then Spider-Man comes and Spider-Man applies a lot of force there and stops the train. So we can say this is the unbalanced force. So unbalanced force actually can stop the moving object. Then it can change the speed or velocity, we can say. It can change the speed. Then it can also change the direction. What about shape? Can it change the shape? Yes, it can also change the shape. These are the all points you should remember about the unbalanced force. So we have seen here two things, that is balanced force, unbalanced force. 2 points about the balanced. First, it cannot change velocity. Second, it can change shape. About unbalanced, it can give motion to the stationary object, it can stop to the moving object, it can give speed, it can give direction, it can change shape. Simple, right? So then let's move to the next point. So we already seen the balanced and unbalanced force. So now let's talk about the contact and non-contact force, right? Again, as the name suggests, it is very simple to understand. Contact force means there should be some force between two objects, right? Okay, so here you can see the simple definition of contact force. They have given us the definition. Contact force are involved only when two objects are physically interact or touch each other. Simple, right? So again, we can consider our same example, right? You and your brother are pushing the car, right? Same example. Or you and your friend are pushing the door, right? So this was our car, which was break down, right? You and your brother wants to push this car up to the garage. What you were doing, from this side you are pushing the car, your brother was pushing the car, actually you were on the front side, right? Then your father told you to go back and again you started pushing the car with your brother now. Okay, so have you touched that car when you're pushing? Obviously. So is there a contact? Obviously there is a contact. So this pushing force, we can call this as a contact force, right? Now, in second case, we also seen that there was one truck which now going to carry your car to, you can say, garage, right? Now forget about the truck. There is a string attached to your car, right? And to that truck. So truck is moving, therefore car is moving. Now about the string, tell me, this string is actually applying some force on your car. So the string is in contact with the car. Can I say that? That's right. So this is also, we can say, tension that is applied by the string is also our contact force. Okay. So let's make the three types of the contact force. Right. Or examples I can say. First one is, as you were pushing the car means you are touching the car. There is a normal force between you and car, right? So what is normal force? It's a very simple thing. Remember, if any object is in touching the other object, we can say, consider now this simple example. There is a table kept here, right? Like this block is kept on this table. This block is on the table, right? Let me draw the block here. Okay, shall. So now will look something like this. Yeah. So block is kept on that table. Obviously there is a connection between them, there is a contact between them. So obviously there must be some force. Now, first of all, tell me how many forces are acting on that block, right? Who is applying the force on that? Yes, that's right. First one is a gravitational force. Always remember gravitational force is there on every object, right? Gravitational force is nothing but equal to weight, we can say, right? mg. Mg is our normal force that is called as gravitational force, which is applied by the earth, we can say, right? Why we are considering the earth and why not the other object? If there is another object, book, notebook is there, I told you the reason, right? Because this force between this block and this book is very, very small, right? Negligible, we can say. So when we say the gravitational force, we assume that it is the force which is applied by our earth, right? Simple. Now consider there is one more object which is applying the force on this block. That object is table, right? So this table is also pushing this block upward, right? As I said initially that that block is at rest. In case of door, I said that you are pushing and your friend is also pushing in another direction. Then the door was at rest. Now this block also can lift on the table. You consider your laptop instead of that block or mobile, right? Laptop is on the desk, which is at rest, obviously. So what we can say, there must be balanced forces there, right? So obviously we know that the mg is acting downward, that is the force applied by the earth. There must be another force which should equate this mg. Now that force is called as normal force. Okay, so now you can see these two forces are balancing each other, therefore we can say the block is at rest, and this force is, we are going to call this force as normal force. And this is the type of the contact force. Why it is the type of the contact force? Obviously there is a contact between that block and table, right? So this is our first type of the contact force. Now let's talk about the second force. Second type of the contact force is we already seen that your string was pulling the car. So let's say tension. Tension is our contact force again, right? Simple. Any object which is pulled by, let's say, some string, right? So this part is, I can say this is string, and let's say this is object. We already seen the example for this, right? Consider your object is car and a bigger truck is pulling that car using the string. So just forget about the tow truck. Just consider the string is pulling the car, or in this case, string is pulling the object, right? So again, can we some contact between string and object? Obviously we can, right? So again, this is, we can say, type of the contact force, right? And remember one more thing about this string, right? This concept is also going to help you in now entrance exam in 11 12, as I was saying, right? So string is always the pulling force. So thing to remember about this tension, it is the pulling force. String will never push you or any object, right? However is the system. So consider this is string and this is the block. The string is attached to, let's say, this is the ceiling. What we can see, the string is pulling that block upward, right? Consider another case. There are two blocks like this. Now listen very, very carefully here. Now this is the part of the string. For this block, for the, let's say, first block, this is my second block. For the plus first block, tension is going to act here. It should look like it is pulling, right? For second block, it will look something like this. So always remember that tension is the pulling force. Okay. Then now third type is friction. There are many types of the friction forces, whether it is contact or non-contact. These three we are going to see. As first we seen the normal force, second is the tension, third one is the friction. So anybody tell me, what is the friction? Friction, where we do get to see this force, right? Obviously, friction is the force which is between road and tire of your car. Very easy, right? So can I say this is the only condition where the force appears? Let's say this is the bike, sports bike, very cool bike, right? Okay, this is bike, right? So obviously, as you were saying that friction bike is moving in the forward direction, then the friction will be applied in the backward direction like this. Okay, so can we say there is only car and bikes, there only friction appears? No, not necessary, right? Even if this is the block, and if I want to pull this block like this, let's say I applied some force, let's say F is equal to 10 Newton, again friction will apply in the opposite direction, right? Now, very important and very interesting thing about this friction is it is called as a self-adjusting force. This friction is called as self-adjusting force. It adjusts magnitude as well as direction, right? So now let's see what is the meaning of that. So first direction, now we know that I'm trying to move this block, friction, let's say to the right side, friction is acting toward the left side. Now consider the another case. Now if I apply the force, if I apply this force on, let's say, opposite direction, this frictional force, which is represented by Fr, is going to go into the right side, right? So you can see it is adjusting its own direction, right? It is opposite, it is always opposite to the motion, we can say. Or as I said, it is also adjusting its magnitude too, right? So now consider, as so in our example, we consider first you and your brother tried to push the car, but it was not, you were not able to push, right? Similarly, consider that if this is heavy, very heavy block, and if first, let's say I apply the force 10 Newton, right? Consider any object in your home, we can say, maybe fridge or very big cupboard. If you want to move that thing, right, what will happen? You are applying some force, right? Is it moving? No. But it is not moving because there is friction, right? You will say that it is dependent on the mass, right? Obviously it is dependent on the mass. Why? Because this frictional force is actually dependent on the mass. It has a formula of mu mg, we can say. It is the not the general formula. I can say this as mu n. What is n? N, I can say this is our normal, and in some cases, I'm not saying in every cases, n is equal to mg, right? So you can see that frictional force is dependent on mass. So what you can say, and mu, what is mu? Mu is another thing which is called as coefficient of friction. Coefficient of friction. The meaning of that is, if it is more, obviously frictional force will be more. So it is dependent on what? First, it is dependent on coefficient of friction. It is also dependent on mass. It is also dependent on acceleration due to gravity. If the mass is greater, if you're moving the cupboard, obviously it is not going to be easy to move, right? So consider if you apply the force of 10 Newton, right? Let me call this as, let's prepare a small table. Applied force and frictional force. What I'm saying, if you apply the force of 10 Newton here, frictional force will also become 10 Newton, right? If you apply the force, let's say 20 Newton, frictional force also becomes 20 Newton. If you apply the force on the other direction, frictional force is going to shift on the other direction, right? So if you apply, let's say 30 Newton, it will also apply 30 Newton. Simple thing. So what I'm saying here, frictional force is a self-adjusting force. It is adjusting itself according to the applied force, right? Is there a limit? Yes, obviously there is a limit up to which it can adjust itself, right? Which dependent on this mu mg part. So whatever bigger object, is it the case that we could never move the object? No, right? We will call our friends now. We all together are going to move that, let's say, cupboard or freeze. Obviously, it is going to move, right? So there is limit. There is a limit up to which that friction could occur, which is called as limiting value. Right? We don't have to go into the detail of this right now, but just remember, up to some value, it will have some. It will keep this object at rest. Right? After which you can obviously move that object. Right? Okay. So this is called as the friction, or we have seen the three types of the contact forces, that is normal, tension, and friction. Okay. Now let's talk about the non-contact forces. Okay. So where I should write now? Yes. So let me see. This whole part was about contact forces. Okay. Then I can also say this is the another point, which is called as balanced forces, and this is our unbalanced forces, right? And initially we have seen some types, so I'm just segregating this so it is easy to understand, right? So now let's talk about the contact forces. We know that we have segregated the forces as contact forces and non-contact forces. For contact forces, we have seen the three examples, that is normal, tension, and friction. Now our second type is non-contact forces. So which are the non-contact forces? Yes, anybody? We also have written one force here, right? So first type we can do as gravitational force. Gravitational force is a non-contact force. So it does not need to be in contact. Consider any object, let's say in air, there is one object in air. Gravitational force is acting downward. Earth is attracting it, right? It cannot go upward unless and until obviously we will provide, if we provide a lot of energy to it, a lot of velocity to it, right? It will go above the, or we can say it will move out of the Earth's gravitational field. Right? But that is not the case we are looking for. So just now we can consider if the object is thrown in the air, obviously it is going to come towards the ground, right? Tell me, if this is the ground, this is Earth, we can say, is there any contact between that ball and Earth? No. Therefore, we are going to say this is the gravitational force, right? We have also written the many things about the gravitational force. So you can also write all those things, that it is the weakest force, then it is a non-contact force, etc., etc. Right? Simple. Now let's talk about the second example. Second example is a magnetic force. Magnetic force means what? Now magnet, obviously we know, if there is a bar magnet, this is called as bar magnet, right? You know there is a n pole and south pole like this, right? What it does, it gets attracted to iron, or we can say it attracts the iron. So consider this is a small piece of iron. If you move the magnet closer to it, it will start attracting this magnet, and this force is called as magnetic force, obviously. Right? Again, can you see is there any contact between those? No. Therefore, we are going to call them as the non-contact forces. Right? One more force, we already seen the force, which is called as electrostatic force. Another force is called as electrostatic force. Okay. So for this force, what I can say, this is the force between, let's say, proton, or electron, etc. Right? When there is a force between, let's say, two protons, both have the positive charge. We know that, right? Charge we can represent this as plus Q and plus Q. Tell me, both are positive. Positive will repel each other, right? There is a repulsive force. We have already seen this. Positive, negative will attract each other. Now, there is no contact in those protons or electrons. So obviously we can also say this is also our one of the electrostatic forces, also non-contact force. Simple, right? So what we have seen up to this point, we have seen the different 4 types of forces, and what are the balanced forces, what are the unbalanced forces. Then we also have seen what the balanced force can do, what the unbalanced force can do, right? Like this. Then we also differentiated the forces as the contact force or non-contact force. We can say there are 3 different examples of contact forces. You should remember those. First one is normal, then tension, then friction, like this. Okay. Then also about the non-contact force, you can say gravitational force is there, magnetic force is there, and electrostatic force are there. Okay. Shallow. So these are the different types of forces. Now let's move to the next point. Our next point is state of motion, right? Remember, they do ask the questions in your exam. What is the state of motion? Simple definition we can see on the screen, that the state of motion of any object obviously can be defined as, or can be defined by, its velocity, speed, and direction, right? Or you can just simply say velocity. What is velocity? Velocity is nothing but speed, and we also need the direction also, right? So state means what? What is its velocity? As I already talked about, right? What is its velocity? What is the speed? In which direction the object is moving? All this represents your state of motion. Okay, simple. Here also you can see that if you kick the football, it is going to move into, tell me one more thing, is it going to move into the straight line or not? Right? Depends how the kick, how he has kicked the ball. It could move like this also, this motion, or it could also go like this. If you kick the ball straight in the straight line, it will go into the straight line. Or this motion is called as, anybody can tell me? Anybody can guess what is this type of motion? It is called as parabolic motion, right? You must have seen this in football, or you can say in cricket, when the batsman hit the six, right? It goes at very high, and then it is going to go into the stadium, right? So it is also the parabolic motion. Now, this state of motion is represented by, as we said, speed and direction. So once he hit that ball, we can actually predict, right, where it is going to go. Can this goalkeeper can actually predict, right, where the ball is coming, which side he should go to stop that ball, right, where the force should be applied, how much force should be applied to stop that object, right? Everything is, we can just guess that, right? Or if you use the mathematical formulas or our physics formulas, we can actually find out where it is going to land or how much velocity it would have, right? So all these things we can consider as a state of motion, right? Now, next part is equilibrium. So let's see what is equilibrium. Actually, we have already talked about this equilibrium when we were talking about, we have seen the balanced forces, right? Balanced force, if there is a if the object has some balanced force, obviously it is not going to move at all. That is what we call it as equilibrium, right? So you can see here, if this on this object, F1 is acted from this side, so F1 is also pushing, F2 is also pushing. There is the same case as our car's example. Your brother was pushing from behind, you are pushing from front. Obviously it is not going to work, right? Car will be in the state of rest, which is called as equilibrium, right? Simple thing. So obviously here you can see, for the equilibrium, both the forces should be equal, but in opposite direction, right? Again, I will repeat, both the forces should be in same in magnitude and opposite in direction. So you can consider this F1 here. You can see for equilibrium. For equilibrium, what we can see, force equation. Force should be how much? It should be F1 should be equal to minus F2. Negative sign is there. Why negative sign? Can anybody guess? That's right. Negative sign appears because of the direction. Direction is opposite. So what we can say that it will have some negative sign. Or if you just take that negative minus F2 from RHS side to the our left hand side, what will happen? F1 plus F2, or we can say this is F net becomes 0, right? So if all the forces, or we can say addition of all the forces acting on the object is 0, or no net external force, or we can say object at rest stays at rest, it is called as equilibrium. Okay, this is also our Newton's first law. We can say object which is at rest is going to remain at rest if there is no net external force. Again, net external force is a important part. We are not saying that there is no force, right? We have also taken the example of your door. You and your friend are pushing this door, right? Guys were pushing this door. So tell me, before pushing this door, right, there were no forces. Still it is at rest, right? Can I say it is equilibrium? At equilibrium? Obviously it is at equilibrium. When you both started pulling, we can say, both started pulling with the same force. Can I say it is at equilibrium? Yes, even though you are pulling the door with the same forces, it is still in equilibrium. So consider what I can write here. F1 is equal to minus F2, right? We have seen what is the importance of negative sign. It is in the opposite directions, therefore it is negative. Or I can also say F1 plus F2 is equal to 0. Simple. Good. So this is called as equilibrium position. This is our equilibrium position. So what we were saying, important condition for that is net force should be 0, right? We are not saying that no force should be there, but net force. Now assume if there is some other friend is there, your first friend was applying the force F or F2, we can say. One more friend of your comes there and he started this pushing this door or pulling this door with the same force. Let's say F3. Now what will happen? Door will open, right, on his side. Can I say this is equilibrium condition? No, right? Why? Because now the door is going to move, obviously. Therefore, it is unequilibrium, non-equilibrium condition, we can say. But consider if you increase your force, or now you are pulling this door with two hands, applying the double force. Now, can we say that all the forces will again become 0? Can I write the force equation? I have written force equation like this. Similarly, now let's write the force equation for using these four forces, right? So tell me, F1 is towards your side, plus F4 is your side, is equal to F2. It should be negative, right? It is opposite. F3 is opposite, right? Finally, force equation, I can also write this as F1 plus F2 plus F3 plus F4 is equal to 0. This is nothing but I can again say F net is equal to 0. So as long as total force, net force is 0, doesn't matter how many forces are acting on that, right? As long as total net effect is 0, object is going to remain at rest and it is called as equilibrium. Simple. Now, what is non-equilibrium? We already discussed this, right? As I said, if the two friends came and they started pulling door on their side, obviously it will not be in equilibrium, right? So your F2 plus F3, if it becomes greater, it is not going to remain at rest. Simple. So you can say that door will open or there will be non-equilibrium condition. Now, instead of considering the F2, F3, F1, F4, four forces, just consider two forces. In this diagram, this is the object. Consider it could be your door. Right? This is the F1 force. This is the F2 force. If the F1 force is greater, obviously, if this is, let's say, 5 Newton, I can consider this as 10 Newton. Will it be in equilibrium? Obviously not now, right? It is going to, this object is going to go in this direction as 10 Newton is greater than 5 Newton, simple. So what I can say in this case, F1 is greater than F2, or I can say minus F2, obviously. Why minus F2? Again, opposite directions are there. Or I can say F1 plus F1 minus F2 is equal to F net, right? So what will be the net effect? We can say 10 minus 5 is equal to 5 Newton will be our net effect, we can say. Therefore, there is a net external force. Object will not stay in rest. Object is going to accelerate. This is your Newton's second law of motion, we can say, right? So we have seen the two laws. First law says about the equilibrium. Second law says about the non-equilibrium. In second law, what we can say? It is not going to remain in state of equilibrium, right? Sure. So this is all about the equilibrium and non-equilibrium. Okay. Now let's talk a little bit about the first law of motion. We already said that it should be in equilibrium, right? The forces acting on the object should be equal. Then we can say it is in equilibrium. One more thing I said about this, that object is at rest, right? So can we use the same concept for the object which is in motion, right? Let's try this one. Now consider first law of motion, that is Newton's first law of motion. What it says? It says object will remain at rest or uniform motion in straight line, right? So we made the two things there. One case one, he was saying object is at rest. So consider this ball is at rest here on the ground, or he is saying that object is in motion. This ball is, let's say, is rolling on the floor, you know that, right? It will remain at rest. Object which is at rest is going to remain at rest unless external force is applied that it. So if nobody pushes it or kicks it, obviously it is going to be at rest. That's very easy to understand. But Newton also said one more thing. If this ball is in motion, right? Remember, if the ball is in motion, he said that ball will remain in motion. It will never stop, right? Is it right? No, right? If we throw the ball on the ground, after some time it is going to stop. You know that. So is Newton wrong? Is this statement wrong? No. Why it is not wrong? Consider, he says the object will remain at rest, which is very easy to understand, not a big deal, or in uniform motion unless compelled to change its state by the action of an external force. Unless compelled to change means unless stopped or direction is changed by the action of external force, right? So when he was talking about this ball is moving, he is assuming obviously there is no external force, right? But in general there are a lot of force which are acting on this ball, right? So consider if I throw the ball on the ground which is rolling on the ground, which forces are acting on that? First force is obviously the friction, first important force, which we can call this as frictional force. Frictional force is acting, we already have seen friction force opposes the motion, it acts opposite to the applied force or the motion, we can say in this case. So friction force is going to stop it. There is one more force, that is air resistance. So air resistance is also going to stop that ball, right? These forces are external forces, right? So unless and until these forces are there, that ball will keep going and going and going. But obviously we know friction is obviously going to be there, air resistance is going to be there, right? So Newton was not wrong, Newton was correct, right? In the second diagram also you can see, if this is the motion, we have to see how many forces are acting on that. Obviously mg is acting downward, you can see, right? So then air resistance, frictions or extra forces are also acting on that. So ball will obviously go here up to here, right? So what you can see, when the ball is going down, this mg means gravitational force, is helping him, right? Obviously gravitational force wants to bring the ball down, so it is going to help him. But after that, ball reaches here and it starts going upward. Gravitational force is going to oppose it. It is trying to again take that ball back to this position, mean position, right? We can call this as mean position. So there is the simple statement of the first law of motion, we can say. Okay. Now, okay, so let's try some questions here, then we can stop for today. So first of all, let's solve this question. Let's understand what are the concepts in this question. So first question says, why do the passengers in moving train suddenly feel a jerk in forward direction when the train stops abruptly? Right? Instead of train, it's considered bus. We are all familiar with the bus, right? Consider bus is moving, right? You are sitting in the bus like this here, right? Driver is here on the chair, obviously. Now consider if uh, he applies the brake there. You must have seen that or observed that or experienced that, right? When driver applies the brake, what happens? You got pushed to the front seat, right? If you're not careful, you may hurt yourself, right? Why this is happening? And that is our question. Instead of us, they just talked about the train. Why it is happening? Is anybody pushing you from behind? Is the passenger behind you pushing you? No. So where is the force, right? And why this is happening? Let's read out the options. So first option says the upper body of passengers continues to be in the state of motion, while the lower part of the body, which is in contact with the seat, remains rest, right? So can we say this is the explanation, right? Upper part, which is not in contact with the seat, right? It is moving, right? When the train suddenly stops or applies the brake, what happens? The upper body, which is moving, it's remain in the state of motion, and the lower body, which is in contact with the seat, remains at rest, right? That's why our upper body goes forward to the next seat, we can say, right? So this is our correct option, obviously. Let's read out the other options too. Second option says the back of the seat pushes the passenger forward. No, it is not happening, right? The inertia of the rest stops the train and takes the passenger forward. Now, inertia means just here, just remember inertia is the inability of body to change, right? Let's do not get into detail of what is inertia right now, right? Just remember, consider any object don't want to change, right? That is called as inertia. So that inertia of the rest means we have applied the brake, right? Train stops. So inability of body to be in motion, that is called as inertia. It is going to take passenger forward. Obviously, it is not going to happen. So this is also wrong. This is also wrong. And nothing can be said due to insufficient data. No, we can obviously got the first option as correct option, right? Now, let's talk about the second one. Second question says that two boys A and B are applying the force on a block. If the block moves towards the boy A, which one of the following statement is correct? Right. Let's draw a simple diagram here first. Now this is one boy here. Right. Consider he is pulling this block. Let's attach some string here. They haven't said whether they are pulling or pushing. Now just consider this boy is pulling and there is another boy here. Right. And this boy is also pulling this here. Okay, so both are applying the forces. They are saying the block moves towards the boy A. So this is our A boy, this is B boy. The block moves here. What will be the correct explanation from the options? Let's see. What are the options? First, magnitude of force applied by A is greater than that of B. Then Okay, just 1 minute. Okay, they haven't mentioned whether it is pushing or pulling, but it's not assumed it is pushing. They haven't mentioned the string, so consider the different scenario. If this boy is pushing the block, consider it is he is pushing. Similarly, second boy is also pushing. Right? Well, they're directly applying the force. No? So instead of using the string, say they are pushing. Okay. Now what happens in this case? The block moves towards the A, like this. So very simple logical thing here. Tell me, who is applying the greater force, A or B? Obviously B, right? So can I say force by B is greater than force by A, right? So let's see which option is correct. First, magnitude of force applied by A is greater than B. No, B is applying the greater force. Then second, magnitude of force applied by A is smaller than B. That's right. So this should be our answer. Let's read out the other options too. Net force on the block is towards B. No, it is towards A, right? Yeah, because block is coming towards A. Magnitude of force applied by A is equal to that of B. Obviously not. If it was the equal force, then we could have said it is in equilibrium and block will be at rest. But block has moved, so this is also wrong. Okay, simple. Now let's move to the next question. Next question is a theory question. State of motion is described by. We have already seen this question. It is described by what? State of rest as well as motion. It could be at rest, it could be at motion, doesn't matter, right? Simple. Then again that question is repeated here, right? So answer we already know, or both by the state or motion we can say. Yes. Next question says, if in a tug of war, you know the tug of war, right? Everybody knows the tug of war. What happens in that game? There are two teams like this, right? Second team is from this side. We also have seen that in the video at the start, right? So I'm hoping that everybody knows tug of war. Two teams are pulling the rope, and whoever is able to pull the rope, then they will win, right? Simple thing. Then in tug of war, when two teams are pulling a rope, the rope does not move towards any team. What is the meaning of that? If it is at rest, what we can say? Obviously, forces should be this team, should be equal and opposite. The force should on the this team. So let's read out the options. Equal forces is being applied in the same direction. Are they applying the forces in the same direction? No. The red team is applying on the, let's say, right side. Green team is applying the force on the left side. So those are not in the same direction, right? Then, so this is wrong. Let's talk about the second option. Equal force is being applied in the opposite direction. Perfect, right? They are applying in the opposite direction. No force is applied in any direction. No forces are there. And D is not right. So obviously B is our correct option, right? So today we have seen some concepts and some questions also. So I will recommend that go through the homework which is already provided, and also read out whatever portions we have covered, whatever the force is, then the different types, right? Revise all those things, right? And if you do have some questions, please post them onto the forum. So we will get back to you on that, right? Sure. So I think today we'll stop here. Tomorrow or in next session, we are going to continue with this chapter, same chapter. Okay. What we are going to see, we are going to see the friction force in detail, normal, what are the normal forces. Then a very important concept is there, which is called as free body diagram. Right? Free body diagram means the body, whatever forces are there, which are acting on the body, we have to denote that in the diagram. Right? Very important concept. Again, I will repeat that it is also going to be very important for your JEE examination, not only for JEE, but if you do go into the engineering field, that free body diagram is going to be a very important concept there. Okay, so we'll also see what is the free body diagram. Okay, So again, if you do have any questions, post them into the forum. And today we'll stop here. So thank you very much, and